Good afternoon, everyone. My name is Justin Mattson. I'm a developer advocate at Google with the distinct pleasure to work on the Android project and talk to you guys today. My co-presenter later will be Pavel Petrek that will talk some about his application development experiences and some tips. So today I'm here to talk to you about what's new in Android and outside of just the API, but some of the things around the Android API itself and the latest things in Android 2.2, which is Froyo, of course. We use them interchangeably. So let's get started. First of all, apps monetization. I'll skip through reading off all the lists of things and get right to the point that I'll get asked later, probably, but we'll respond to immediately, which is the lack of the Czech Republic for being a seller country. So the Czech Republic will be a seller country. It's a buyer country. Sorry? When? When? The question is when. If I were a fortune teller, I wouldn't be on stage, right? So, no, so this is something we're obviously quite concerned about, and we have added Czech Republic as buyer country, so I'll ask you to take that as an act of goodwill, that we are moving forward with it. And then obviously around monetization, there's the market licensing server, which when the Czech Republic becomes a seller country, will be quite useful to developers here, and I'll just go over it briefly, basically. So the market licensing service is a replacement for the use of copy protection or forward-locked apps. And there are some big benefits for you as a developer, which is that no longer does there need to be coordination between Google and the OEMs to make sure that we know about phone configurations and other things out there, because periodically we'd run into this situation where people selling apps would contact us and say, there are 1 million people with this device, and suddenly they can't see my application. So it eases that burden. It also means that who's running a modded device out there? I promise I won't report you to anyone, like Cyanogen or something like that. One person? All right. 2, 3. So market licensing server will work on those devices as well. And the main way this works is through, well, the easiest way for you as a developer to use it is one of the add-ons to the SDK, the licensing verification library, which manages all the communication. And like I said, this is available to pretty much all devices out there. You only need Android 1.5 or higher. So quickly and architecturally, all of the hard work is done by the market process, and your application process does a series of binder calls over to the market process, and then the market process is the one that's communicating with the back-end server. And in the future, when you add this to your paid applications, there's some best practices to follow, because shortly after we released the licensing verification library and service, some people pointed out that it wasn't tamper-proof. So there's some best practices to use as you're incorporating this into your app. And the first is to use an obfuscation tool. So it's kind of ironic, we all spend a lot of time writing readable code. So we can go back in a year or a week, if you're me, and figure out what it is you wrote previously. And unfortunately, that readable code ends up being useful to hackers that are trying to reverse engineer what your code is doing. They can see everything that's going on. So the irony is we use these obfuscation tools to undo all this hard work that you guys have been doing. So also in terms of code modification, you can modify the licensing verification library yourself. Or you can actually not even use it. So you can look at how the implementation is done and actually do the raw binder calls yourself. Both of these methods are trying to make your code less generic, so that a would-be attacker won't see a common pattern. Another thing that you can do is to checksum yourself. So take a checksum of your entire APK, and then when your app is running on the device, what you can do is read that APK file back and see if the checksum matches. You might also store that checksum remotely because, again, anything on the device is somewhat untrusted. Someone can decompile your application and modify the code and then compile it back. And there are more and more applications out there where a lot of the functionality is provided by the server side. So think online games, particularly, many other things where a lot of the resources are online. And for these types of applications, there's an additional option, which is when you get that licensing verification response back from the server, you can forward it onto your own server. And then you can do the verification there using the public key to decrypt the raw response from the market licensing server and see if it looks, appropriate. If it has a timestamp from a few days ago, it's probably, it's a replay attack, obviously. So the licensing verification library is more flexible. It gives more power to you guys, to the developers, to decide what to do. Because under the previous system, it was basically binary. If there was an untrusted device configuration out there, basically that copy-protected application couldn't be run. But now you, the developer, have the choice to say, well, maybe the app won't run, maybe it'll run with reduced functionality, maybe it'll run at full functionality for a couple of days or something like that. And the second two options are basically giving the way a user to try out your application, perhaps before going ahead and buying it. And when you launch the app, you might say, oh, I notice you seem to have acquired my application from an unauthorized source, but kind of let you play around with it for a while anyways. So a lot more flexibility for you, the developer, and a more pleasant experience for the user as well. Another technology that is not part of the API itself, but part of the ecosystem that surrounds Android, and again, part of Android Market, is error reports that you can get. So now if you see comments on your application that say crashes on this device or on this configuration, if I check this box, it crashes. So you'll be able to get reports like that, and even better, get a stack trace of where the error happened. So perhaps there's some user configuration that wasn't anticipated and is being flexed, some disused area of code, or just something you didn't anticipate. So this gives you a lot more power as a developer to figure out what is going on, respond to the comments of your users, and make a better application in the end. So those are some of the things that are surrounding Android as surrounding what's actually running on the device and the actual API. So I want to turn now to the device and what are some changes that you can take advantage of there, technology actually running on the phone. What's in the APIs, the SDK. The first feature that you can take advantage of is speed. The great thing about this feature, you have to do nothing exactly to take advantage of it. It's there automatically. So at Google, we think one of the most important features of any product is being fast. We saw in the early days of the search engine that when we shaved a couple of hundreds of milliseconds off the loading time of a page, people searched more. People were happier with what was going on. And then to our surprise, even if we shaved some tens of milliseconds off, people were happier and used the application more. So, 30 milliseconds doesn't seem like a lot of time, but that's one frame in a 30 frame per second video, basically, which is what we're all striving for, is 30 frames per second or better, right? So those small amounts of time do make a difference. And one of the key ways that Android is faster in 2.2 is with the just-in-time compiler that takes your Dalvik bytecode and compiles it down into machine-level code on the fly. So I'm sure we're all familiar with just-in-time compilers, but I want to say just another couple sentences about this one because I think it's really cool. I've talked to the people who wrote the just-in-time compiler, and they said the total amount of the total amount of code in the just-in-time compiler is something like 80K. And for that 80K, the just-in-time compiler doesn't recompile your entire program into machine-level code, or whole classes, or even methods. It looks for the hotspots in your program. It's a tracing JIT. So it finds the hotspots, translates them, and adds them to a translation cache, which it accesses later if it sees the same stretch of code being used again. And the other great thing about the JIT in Froyo is it's a really small in-memory footprint. It's 100K. So for 100K of memory and less than 100K of code, you can get things like 2 to 5 times speed ups in, obviously this is not suddenly every part of your application is going to be 2 to 5 times faster. But if you, in micro benchmarks, I ran LinPack, for example, which is about 7 times faster, I think. So in small places, you can get even better performance increases. But of course, Android is not just about native application performance. It's also about web application performance. And the key to a fast web application is a fast JavaScript engine. So in 2.2, we went from Squirrelfish Extreme, which we'd been using before, to the V8 engine, which is the same JavaScript engine that drives Chrome. And this drives a 2 to 3x speed up in JavaScript performance in the browser. In both these categories of speed, we need to make things faster. We're working on a better JIT for the future, and we're working on improvements to V8 to make the mobile browser even better, to deliver an even faster mobile web app experience. Another feature request, or some people call them feature requests, some people call them complaints, is that people want to use their Android in the corporate environment, but their IT administrator says, no, you can't use an Android device here. It's not secure enough. It doesn't have the features we need. So in 2.2, we added a device administration API so that the operating system would be compliant with lots of those policies, basically the exchange security requirements, right? So I want to go quickly over what you might do if you were building your own device administrator, because as so many things in Android, you can write a device administrator that's not part of the system. It's just another application. And this is another place where I really love Android, where we're bringing the ability to put very deep system-level functionality in the hands of application developers. So if you wanted to write your own device administrator, like I said, it's just an app, which then might request a security policy from the server, or have a default installed, get the security policy back, and then enforce it. And that security policy might be things like minimum password length, what to do when password entry has failed a number of times, and you can even do things like wipe the user data. So if you think the device has been lost, you can erase the data. So the first step in writing a device admin is to have a manifest entry that basically says you're capable of administering the device. So you have a receiver, which is a descendant of the device admin receiver class. And then, excuse me, you declare 2 important things. One, that the application is able to bind to the device administration service, and 2, that you will respond to intents that device administration applications are expected to respond to. And then you also define in another file the metadata, some additional metadata, and this is basically what policies you want to take care of, which are these. Now, you don't have to administer all of these policies, but you have the option if you want, and that's why there's this additional metadata file. So the other thing that another thing that I'll note is that the user has an additional level of warning about device administration applications. So I said you need to be able to bind to the device administration service. And when your application attempts to do that, typically upon the first time it's run or something, the user gets an additional warning that says, hey, this application wants to administer your device. Do you want to allow this? So if you ever download an app from Market that requests this, or your friend says, hey, install this APK on your phone, it'll do fun things. You might think twice about that, because they can lock your screen, reset your password. Indeed, fun things. Good for April Fool's Day, perhaps. And so the implementation of the receiver is something like this. So the receiver gets a number of notifications. For example, if the password has been changed, you might want to notify your home server that this change has happened. If the password entry has failed, you might want to take some custom actions depending on the number of times it's failed. Importantly, you'll also get callbacks when the device administrator is enabled and disabled. So when it's enabled, you want to set you want to enforce the settings of your policy. So maximum number of password attempts, how long until the screen locks, things like that. Now, on disable is interesting because you actually get two callbacks related to disabling. One is that the user is requesting that your device administrator app be disabled. And there's actually an error in this slide. It should say that on disable requested returns a character sequence. And that character sequence is anything you want to tell the user. Like, if you proceed with this and disable me, I will erase your phone. Because if a device administrator could be uninstalled without any consequences, it wouldn't really be very secure. But in the corporate IT environment, if you say, all right, if you become an unmanaged device, I'm just going to erase everything because I can't trust you anymore. So, and if the user goes ahead and says, yeah, I want to disable this, you get the on-disable call. Now, in on-disable, your application is still able to do all of the things a device administrator can do, but this is the last chance. You're being uninstalled, so do anything that your IT policy indicates that you must. And so having the device admin functionality in the operating system, we think, is going to allow a lot more people to use Android in the workplace and in their corporate IT environments, which is something that I'm excited about because I think Android is pretty much the best tool for most environments out there. And I'm excited that more people will be able to use that great tool to their advantage. Another thing that I want to talk about, and I'll go over kind of quickly because it's been mentioned before, is cloud-to-device messaging. And it's been mentioned before, but I mention it again because it is the coolest feature in Android 2.2 and the coolest feature in the system for quite a while. Who out there has an Android application using cloud-to-device messaging? Okay, a few. Wow, that's actually more than the guys in Moscow. So that's great. How many don't have an app that doesn't use cloud-to-device messaging, but they have it would have a use for it? What are you waiting for? Because C2DM, which is our abbreviation for it, is great. It has, again, it's a win for everyone. You, as a developer, can get rid of that nasty, antiquated polling logic where it's like, okay, wake up every 15 minutes. Is there something new? No, okay, there's nothing new. And what if my process gets killed? Or what if something happens and the alarm doesn't go off correctly? Now it doesn't matter. Your application just gets notified when the server, when your application server decides that something interesting has happened. And for the user, it's a win too, because you're not, your app isn't killing their battery going, is there something new? Nope. Is there something new? Nope. So I work with a partner that was trying to do push with Jabber or XMPP. And they moved to cloud-to-device messaging. And they did performance testing, and for battery performance, that is. And for sitting there doing nothing for 4.5 hours, Jabber used something like 60% of the battery on the device, which is insane for, for nothing but to maintain a connection. Cloud-to-device messaging, sitting there doing nothing, is like 2%. Something trivial like that. So in addition to better battery performance, the user gets the data when they want. I need those tweets now. So I can find out what's going on at GDD check without being there. So it's a big advantage. I encourage you to use it in your applications. And just briefly, the flow is that the device, when your app gets installed on the device, it requests a token from the C2DM servers, which it gets back, passes on to the third-party messaging server, well, your server in this case, the application server. And then the application server includes that when it wants to send a message. The message will get to the user. It's what we call a tickle, so it's not the information. It's just, hey, hello, there's something interesting that's happened. Phone home. So then your device can phone home and get the all-important tweets just in time to wake the user up at 2 in the morning because they forgot to turn it off. Another API, and I don't know if you've seen a theme yet, but most of these APIs are in some way dealing with being connected to the network. And that's because the most interesting things now involve the network and talking to the cloud. And I talk to developers and I say, if you don't need the internet permission, you're doing something wrong. There's almost nothing out there that can't be made better by talking to a data center full of thousands of servers, unlocking a huge amount of computing power. And another one is backup. So in Android Market, we already restore all the applications of a user when they get a new device or when they wipe their existing device. What I'd like to encourage you as developers to do is restore their data too. Because then if I've gone through the awful experience of losing my phone and getting a new one, I get the new phone, the applications come down, the data comes down, and I'm off and running again. So if you want to incorporate this into your application, this is the high-level overview, at least, of how you do it. So you've got your application here with the application data, some shared preferences, files, SQLite databases, etc. So what the program then needs to plug into is the backup agent, or into backup agent helpers. So how this works is, if you write a backup agent helper, basically it translates from the file or data format on disk to the cloud storage backup API format. And that format that sits in the cloud is just a bundle of name value pairs. So you've got, okay, this name maps to this file, and this name might map to this row in the database, et cetera, et cetera. So you can either extend backup agent, which will give you a bunch of control, or if you've only got shared preferences and local files, you can use the helpers that are already in there, and they know exactly what to do when do backup gets called. And basically, the one important thing to keep in mind with do backup is it's not meant to be a full backup. This happens periodically. It's meant to be a delta from the previous one. So we haven't written a helper yet for SQLite. I hope we will next, but basically what that would look like is it would monitor the rows that have been changed since the last backup and update just those rows instead of updating the entire database, because that's inefficient. So once you give your data, backup agent gives its data to backup manager. And then once it's given to backup manager, there's a transport service that takes it to wherever it's being stored in the cloud. Now, by default, this is somewhere in Google servers. But I'll note importantly that a manufacturer or a carrier could change this to be their own data store of some variety. The next API, and really sort of a final API proper that I want to talk about, is speech. Speech is a really important new input method. And in order to harness it, basically what we've done is taken advantage of that giant data center with lots of processing power. Now, unfortunately, in the first version of the speech API, it was pretty opaque. You said, please recognize some speech and please give me some translation back. There's very little other feedback there. But now the speech API is growing up, getting more mature. One of the things that's important is now we've exposed the recognition service APIs. So you as developers could actually write your own speech service if the default one doesn't support a given language that you want to support or something like that. Part of recognition service is the callbacks. These provide that more granular information that I was talking about. So the application developer that's using the service knows when speech is starting, when it's stopped, if partial results have come back, etc. So those are things if you want to write your own recognition service, but let's say that you just want to use it. Well, there's more flexibility there as well. So you're able to control more of the parameters than you were before instead of saying just recognize speech. And the final thing that I'm going to talk about is install on SD card. So this isn't an API proper, but it is a very important feature. And it's one that I'm surprised how many, not how many developers, how many users are aware of it. How many times I see in market comments, 3 stars. When you add install on SD, I'll put 4 stars. So who had or has a G1? Not many, oh, that's a few people. Who thought it had enough storage space? Okay, good, none of you are insane. Because it didn't have enough storage space. But the SD card has lots. So let's store the applications there. Now, there's obviously some important caveats with install the SD card. If you're running a widget or a service that needs to run all the time, then your app is perhaps not going to perform the way the user will expect, because if they unmount the SD card, the widget will die or the service will go away. So to use this, again, it's very simple to get this power and functionality. You just set the install location bit in the manifest. Now there are 3 options to this. One is prefer external. The other is internal only or something to that effect. And the third one is auto. Now you might say, I should set prefer external, which seems logical. But I'm going to lobby for setting auto, because if you set prefer external and your app is installed while the user has mounted the SD card on their computer, the installation is just going to blow up. It doesn't work properly. There's a bug, or perhaps we'll say a future feature of doesn't blow up when you set prefer external. So apologies for that, but auto will the system will put things where it thinks is best. And then importantly, the user will have the option to move to SD card in the future. So they get the feature they want. You don't have to worry about installation failing. Again, pretty good situation. So there are a number of new APIs in Froyo that are important for developers. Hopefully, I've gone over a good number of them here, but there are more, and if you want to read the, oops. Apologies. If you want to read more, you can go to the highlights. So, I didn't talk about Wi-Fi hotspot or UI modes, things like that. The other thing I'll mention is documentation. Who's using Stack Overflow now? Who thinks it's better than groups? Yeah, me too. So thank you all for participating in that. And also I'll mention our mobile products URL. It's things like analytics, ads, stuff like that, that you can add into your application that will make it better. So these are some of the new APIs in Froyo, but there are a number of features and APIs out there that have been in the system for a while, but they seem somewhat unknown. And as someone once said, if it's new to you, it's new anyways. So Pavel Petrek will hopefully come on up, He's going to talk with you some about his experiences in developing with Android and some great features that you can take advantage of as developers and not enough people out there are using. He's the CTO of InMight, so Pavel, I'll hand it over to you and try to switch to your presentation.
Thank you, Justin. And similarly to my colleague during keynote, I will prove that I'm real Czech and I will switch to Czech language. Takže ještě jednou dobré odpoledne, jmenuji se Pavel Petrek a to, co ode mě uslyšíte, can we?
Yeah.
Okay. To, co ode mě uslyšíte, tak jak už jste pochopili, není zdaleka novinka v Androidu, je to ba co víc, v podstatě je to v Androidu úplně od samotného začátku, ale sadím se, že většina z vás, jakkoliv o tom slyšela, tak to ještě pořádně nepoužila. A tím jsou konkrétně styly, vše kolem stylování, skinování aplikace, jak si můžete usnadnit práci a jak můžete ušetřit čas. Tak představovačku tu si můžete stáhnout, přečíst později. O čem to bude konkrétně? Nejprve se podíváme na styly a témata samotná a v druhé části nebudou to teda jenom plusy, budou to i nějaké drobné mínusy, protože to není samospásné řešení. A v druhé části se mrkneme potom na to, jak v podstatě tohleto skinování podchytit bez použití jediného PNGčka, v tom ideálním případě. V průběhu plynulých přednášek už jste tady slyšeli takové ty důležité rady, že bez UI designera byste se do toho neměli pouštět, že jako programátoři prostě nikdy neuděláte tak dobré UIčko. Já si to nemyslím, pokud se v tom poli chviličku pohybujete a máte trošičku cit pro tohleto UIčko, tak speciálně ta druhá část bude úplně pro vás jako stvořená. A doufám, že zbyde trošička času na předávání nějakých QRů. Tak, seznamte se, tohle jsou Google kozy. A na začátek by bylo dobré říci, co rozumíme stylem a co rozumíme tím tématem. Stylem teda rozumíme nějakou sadu properties, sadu vlastností, které určují, jak nějaká konkrétní komponenta ve vašem UIčku vypadá, jak je naformátovaná. Oproti tomu téma je v podstatě takový obecný styl, který je aplikovaný na aktivitu jako celek a všechny komponenty v ní, případně na úplně celou aplikaci. Takže vlastně jednou definicí vy postihnete UIčko nebo podobu toho celku. Teď se podíváme, jak se k tomu typicky právě přistupuje a jak se tím jako vývojáři můžete prokousávat. To, s čím přijdete jako první většinou do styku, tak je právě tady tenhle ten spaghetti inline kód. Jde o to, že v podstatě veškerý styling, všechny velikosti textu, barvičky textu, způsob zadávání z klávesnice, layout nastavení, padding, margin, borders, prostě všechno cpete do jedné špagety. A to nemusí být špatně. Pokud stavíte aplikaci s 1, 2, 3 obrazovkama, se kterou nemáte ambici nějak rozšiřovat, se kterou nemáte ambici nějak udržovat, aby prostě přežila dlouho na věky, tak v podstatě s touhletou špagetou ve chvíli, kdy dosáhnete funkčního celku, tak si můžete krásně vystačit. No, jenomže potom přichází čas na serióznější aplikace, kdy plánujete, že teda když se to trošičku uchytí, tak bych to dál rozvíjel. Můžete mít rovnou od začátku plány na to, že to bude opravdu velké. A v tu chvíli se vám začínají hodit styly. Je to v podstatě taková generalizace, nalezení těch společných stylových prvků, jak to znáte v podstatě z webového CSS a vydefinování těchto balíčků jako samostatných stylů, které můžete aplikovat na jednotlivé komponenty. V podstatě to funguje tak, že opravdu ty jednotlivé property slepíte. A teď nevím, jestli to. Jo, ty jednotlivé property slepíte takhle do definice stylu a v okamžiku, kdy ten styl použijete, tak všechny ty property jsou zkrátka aplikovány na vaši komponentu. Uspoříte tím určitě kousek času. Nicméně můžete jít ještě kousek dál a to jsou právě témata, kdy vy v podstatě si nadefinujete do themes XML si nadefinujete všechny tyhle ty styly, spojíte je do jedné definice tématu, řeknete, které komponenty které komponenty v tomhle případě tadyhle button chcete stylovat a od toho okamžiku už se nemusíte starat, pakliže v Android manifestu definujete tohle téma jako použité pro vaši aplikaci, už se nestaráte, jak aplikace vypadá. Ty klíčové přínosy jsou tady celkem zřejmé. Šetříte spoustu času, v podstatě děláte si méně práce, protože prostě neopakujete se zbytečně a co je určitě dost výrazný přínos pro tu udržitelnost do budoucna, tak v podstatě máte separované to, jak to vypadá, to, jakým způsobem to potom interaguje, jak je to rozložené vůči uživateli. Čili si můžete dovolit v budoucnu prostě dělat nezávislé zásahy do skinu, případně úplně aplikaci přeskinovat. Když půjdu trošičku ke konkrétní ukázce, kde třeba nám tohleto stylování a témata pomohla, tak Corkbin, ten už tady zazněl na keynote a když si vezmeme konkrétně screenshot z aplikace, který vidíte na slajdu, tak v podstatě na téhleté obrazovce je jediný image použitý, jediné image view, a to konkrétně pro toolbar, a v podstatě i ten je sdílený napříč celou aplikací. Zbytek je čistě pomocí stylu, teda pomocí stylu zabaleného v tématu. A v podstatě v tématu stačilo vydefinovat opravdu jenom 4 jednoduché widgety nebo jejich stylování, nějaký button, nějaký image button, text a edit text, plus background okna, a výsledek, čísla jsou vidět, co jsme tím vlastně dosáhli, co jsme ušetřili. Máme automaticky nastylovaných nějakých 100 user komponent, view komponent a 15 uživatelských obrazovek a v podstatě cokoliv nového přidáme, tak na 99% se trefíme do tohoto stylu a máme to v podstatě bez práce. Styly nejsou jen tak sami pro sebe. Styly můžete mezi sebou samozřejmě dědit, abyste i v podstatě při tom psaní těch stylů si ušetřili co nejvíc práce. Můžete dědit jak implicitně, to je vám dopřáno v podstatě u vašich vlastních stylů, které pomocí tečkové notace, a to máme, jasně, pomocí tečkové notace můžete rozvíjet cokoliv jakoby s tím základem před tečkou je vždycky poděděno, plus máte ještě explicitní dědičnost, kterou můžete dědit od jakéhokoliv systémového resourcu. Ty plusy, ty jsou jasné, ušetříte si to copy-pastování už i při samotném definování stylů. A ten mínus je tady celkem zřejmý, hlavně u toho explicitního dědění, kde vy můžete dědit vlastně z resursů, které nejsou tak úplně vaše, které vám dodal výrobce telefonu. No a tady právě je potřeba si dávat bacha, protože výrobce telefonu může sice vzít defaultní look Androida, takže vy, když budete dědit, já nevím, z nějaké podoby edit textu a řeknete si, fajn, tak mně se to líbí a jenom bych tam vlastně upravil si velikost textíku trošičku a přidal barvičku, tak se vám může stát u některých výrobců, že ten hold jakoby přidal ještě nějaké vlastnosti, které vy jste neočekávali. Může to být cokoliv s barvou, může to být se stylem textu, může to být nějaký explicitní padding a v tu chvíli váš zděděný a dopracovaný, rozšířený potomek bude vypadat prostě hrozně. Takovou nejprvnější ukázkou, která se tady objevila, tak byl telefon Hero, kde HTCčko si řeklo, fajn, odlišíme se, nebudeme používat oranžové fokusy, oranžové položky, ale budou zelené. A ve chvíli, kdy vy jste dědili svoje styly a v podstatě ladili ty svoje doplňky do oranžova, tak na té zelené to vůbec nevypadalo dobře. Zní to jako krásné řešení, ale určitě to není samospásné, čili není to tak, že byste mohli použít úplně beze zbytku, bez jakéhokoliv dalšího zásahu do definice layoutu. Tím prvním důležitým bodem je, že v podstatě popsaná dědičnost nefunguje vícenásobně. Není to jako ve webovém CSS, kde na jeden nějaký konkrétní tag můžete aplikovat několik tříd, jednou na základě třídy, jednou na základě IDčka, jednou na základě toho, že je to prvek tabulky. Tady je mnohem jednodušší ta dědičnost, je to opravdu stromové, to znamená, máte maximálně jednoho předka a tím pádem máte v podstatě skupinu nějakých stromů z několika kořeny, od kterých se můžete takhle oddědit. O to čistší musíte držet tu hierarchii, ale dá se s tím opravdu vydržet. Potom je to skenování dialogů, které vám vyskakují ve vašich oknech. Část z dialogu, jak tím myslím konkrétně background, tak ten samozřejmě si customizujete, jenomže například zmíněný progress dialog obsahuje uživatelské komponenty. Je to takovéto točící se čekátko plus textový popisek. Tyhle komponenty jsou definované v jakémsi systémovém layoutu, v jakémsi XML-ku, které má v sobě hardkodované napevno ty defaultní androidí styly, čili pokud chcete mít kompletně přebarvený, kompletně customizovaný i progress dialog nebo alert dialog, tak hold budete muset třídu overridenout a v podstatě celý obsah dialogu si vytvořit takový nějaký sobě na míru. S tím souvisí taky dialogy stavěné skrze builder, dialog builder, kde v podstatě taky je vám stavěno UIčko na základě nějakých defaultních komponent v nějaké defaultní podobě a v podstatě až do Froja, nebo ještě stále ve Frojovi, vy nemáte možnost říct v konstruktoru builderu, pod jakým tématem má být dialog postavený. Díval jsem se do aktuálních zdrojáků, což pravděpodobně bude odpovídat Gingerbreadu a tam už konstruktor i s tématem, konstruktor builderu včetně tématu je, takže tady můžeme čekat teda zlepšení, ale stejně i když postavíte UIčko pod tím tématem, tak vám zůstávají nějaké textové komponenty, které builder používá, které v sobě mají naprosto napevno zakódované androidí styly. Tak. To bylo ve zkratce teda ke stylům a tématům a teď, když už víme, jak si teda tu práci zjednodušit, tak jak se obejdete vy schopnější z vás i bez designéra a bez PNGček. K čemu typicky používáme v aplikaci nebo ve skenování aplikace PNGčka? Je to aplikační ikona, máme to nějaké akční ikony na tlačítkách, no ale potom to máme taky spoustu použití, pokud opravdu důsledně skenujeme a chceme mít úplně vlastní look aplikace, tak jsou to backgroundy jak celé obrazovky, tak jednotlivých komponent. A to je přesně ta část, která nám vygeneruje při spolupráci s designérem spoustu PNGček, spoustu resursů, které potřebujeme nacpat do aplikace. Typicky, když to srovnám třeba s iPhonem, kde teda si vystačíte jenom s portrétem, protože prostě hardwareová klávesnice není, tak na Androidu v dnešní době už musíte řešit nejméně 2 layouty, nějaký portrétový, landscapeový a k tomu ještě máte 3 různá DPIčka, 3 různé hustoty zobrazení. Ve výsledku to znamená strašná spousta PNGček, pokud chcete, aby vaše aplikace byla opravdu pixel perfect. No a tady je otázka, jestli si teda nevystačíme bez těch PNGček, pokud nám stačí jenom, pokud si vystačíme jenom s nějakými, s určitým levelem toho coolness naší aplikace. No a přesně tady přichází na řadu právě shape jako náhrada těch PNGček. Shape je nějaký geometrický útvar definovaný v XML-ku, máme několik základních geometrických tvarů a my si v podstatě můžeme dovolit od kulatých rohů přes gradienty na pozadí, přes různé okraje, vydefinovat styly, jak potřebujeme a nemusíme k tomu použít jediné PNGčko. Tady vidíte v podstatě sadu 3 jednoduchých komponent, kde v kódu samotném není použité, v layoutu samotném není použité nic extra a vlastně veškeré backgroundy jsou definované jako tady tyhle obdélníčky, případně obdélníček s kulatýma rohama. V základu máte k ruce nějaký obdélník, máte k ruce ovál, máte k ruce kruh a jednoduchou linku. Ručně dokonce linku můžete rozvinout i do nějaké křivky s volitelným vyplňováním a podobně. Teď si určitě říkáte, fajn, tak mám shape, který mi má pomoct s nějakým teda resizováním na různé velikosti, ale proč je to lepší než 9-patch? No, v něčem je, v něčem není. Co se týče těch základních věcí, kulaté rohy, gradienty, ano, tam to vychází zhruba na stejno. U 9-patche si můžeme samozřejmě dovolit mnohem komplexnější grafiku. Navíc máme mnohem obecněji definované ty oblasti po stranách PNGčka, které teda jsou resizovatelné a které ne. Nicméně, když přeskočíme k shapeům, tak v podstatě veškerý ten blok paměti a všechny ty operace, které jsou potřeba právě na to nakládání s PNGčkama, tak si u shapeů můžeme odpustit. Pokud půjdu zase k nějakému reálnému examplu, reálné ukázce, tak to bude aplikace CGO. Je to aplikace českého autora Karnera, určená pro geocaching, podpora geocachingu, a v podstatě UI téhleté aplikace je celé postavené jenom pomocí shapeů, nebo ten skin aplikace. Tady vidíte jeden screenshot, kde v podstatě všechny edit boxy, tlačítka i ty jednotlivé bloky stavební aplikace, tak všechno je postavené jenom pomocí kulatoučkých rohů, hezkých gradientíků a ušetříte si tím určitě dost nervů. Jak sám autor říká, tak v podstatě tím, že použil shapey, tak určitě ulehčil aplikaci jako takové, protože prostě se toho zpracovává při vykreslování UIčka mnohem míň. V podstatě jednou ranou zabil 2 mouchy tak, že pouhým přepsáním nějakých barviček si mohl dovolit udělat k původní light verzi ještě dark verzi, kde prostě jenom přehodíte čísla barev a máte vícero variant, nepotřebujete k tomu grafika. Rovnou máte pokrytá všechna DPIčka, to znamená, když jste na Nexusu, na velmi hustém displeji, máte krásně kulaté rohy, hezky spojité gradienty. Pokud budete na telefonech s hrubými displeji, já nevím, nějaký Vodafone 845, tak máte úplně stejný zážitek s maximálním vykreslením a minimálním zatížením toho softwaru. No a co pro spoustu uživatelů je podstatné, tak vám ten přístup ušetří strašnou spoustu času. Tak, klíčová sdělení z téhleté druhé části. Styly používejte, pokud chcete uspořit čas a mít v podstatě flexibilnější aplikaci. Témata používejte, pokud chcete uspořit ještě více času a vůbec velikost aplikace vám to samozřejmě ale dovolí. A chcete mít ještě flexibilnější aplikaci s nahraditelnýma kouskama. No a shapey používejte tehdy, pokud nemáte designéra, trošičku máte cit pro skládání barviček, skládání shapeů a chcete, aby se vaše aplikace s minimálním vaším nasazením, aby se trošičku odlišila od toho defaultního looku Androida. A teď přichází ta část, jestli máme... Do we have a time for Q&A? Okay, so... We have time for a couple of questions. So if you have any questions for
either topic? Yeah.
Either topic, let's ask.
No one? Okay, yeah. Mm-hmm.
This might be the place to ask since it was a title news or features in Android.
Mm-hmm.
We don't have it yet, but my question is if it's coming, and if it is coming, then is it going to be something similar to what we've seen in that Google Tech Talk about a month ago by David Sachs from InvenSense about a sensor future? Is that the API that's going to appear in the next perhaps?
I'm not familiar with the tech talk that you're referring to, so I guess I can't answer that specifically. But yes, gyroscopes are something that the API will support in the future. I imagine it will be through basically, I think most of the infrastructure that you need is already present in the sensor events that we have, like for accelerometers and things like that. So I imagine it's just going to be another, a different piece of hardware to target, essentially. Yeah, thanks. Additional, yeah.
No, it's done manually in the settings. And as far as I remember, the application, when the application starts, it checks the settings and decides which one, which of the themes it actually uses for the application look. So it's manually. Yes. Mm-hmm.
Yeah.
Another question about themes. How can you get the list of themes for your application? Can you get as a list, or do you have to hard code for settings?
What exactly?
Dark theme and light theme.
Yeah, it's these two are our default ones built into Android.
Okay, so for example, you have all themes.
Mm-hmm.
So how can you get the list? You have to hard code the application.
Of course. There is no such way that you would like create themes, put it into Android Market, and share it with the other people. You have to create it and build it into your application.
Yeah, but it sounds like a good idea for an API that you can access what, right, yeah.
But right now, there's nothing like that.
Yeah, I'm not aware that there's something like that. If it existed, it would probably be through the resources class, but I don't think it exists. Well, we're short on time, and I don't want to get the afternoon running as late as the morning was. And plus, I'm sure you're all waiting for Dan's talk about the NDK, which is awesome, by the way. So I think we'll wrap up here. Thank you all. Thank you, Pavel. And yes, thanks for coming. It's great to be here in the Czech Republic. Thank you.
Thank you, Justin.
Yep.